Hello and welcome everybody to our introduction of a really exciting new Gates TPU product. My name is Heinz Watzinger. I'm Product Line Manager for the Gates TPU Product Line, and I'm happy that you joined this webinar to learn about our silent self-tracking belt innovation. With the continuous improvements of performance and strength, TPU belts are used in new application fields that were previously reserved for other elements only. Higher loads and longer belts lead to new challenges in the installation and operation of the belt. Facing these challenges, Gates has developed a new belt design that significantly simplifies installation and makes operation more reliable and safer. Hence, you are reducing cost of ownership by reducing installation time, maintenance, and downtime. A few years ago, so-called HOT, helical offset teeth belts were introduced to the market. They have been quite successful and solved problems with noise and self-tracking. However, this belt design is difficult, and so are the pulleys. Only very few pulley manufacturers can make these pulleys, and they are expensive due to the demanding machining process. Furthermore, customers reported belt wear when higher lateral forces apply. Therefore, we developed a belt design that addresses these issues and additionally is available in width up to 150 millimeters, which provide higher tensile strength than any of our competitors can do. So here are the customer's pain points and how we address them with our SST belt design. Belt installation. The longer the belt, the more difficult to adjust the side tracking of the belt on the pulley. Our solution is a pulley-centered tracking ring, which will track the belt ring right in the middle of the pulley. Only minor adjustments to reduce side forces are required. Pain number 2 is competitor belt strength is limited by limited width. And with higher loads, you need to apply multiple belts to achieve the required load handling. Our Gates SST8 RSL belts are available up to 150 millimeter width and offer almost 3 times the braking strength of competitor belts. And pain number 3, HOT belt requires special pulleys, and only a limited market for these pulleys is available, and that leads to some obligation to buy belt and pulley from one source. Our belt SST8 RSL runs in standard HDD pulley pitch. The customer can produce their own pulleys or source them from any pulley manufacturer. Gates will support with the offset tooth design or offer the belt and the pulley system. Here you can see the belt design in more detail. The tracking ring will take the lateral forces with no tooth abrasion, one major advantage to HOT belt. At HOT belt, the pulley teeth wear the belt teeth when high side forces are applied. The offset teeth and the nylon fabric minimizes running noise, especially at high speed. The belt teeth are standard HDD8 geometry, the pulley design that all pulley manufacturers offer. And the RSL high-strength steel cord provides high braking strength and high stiffness for demanding applications. Overall, a belt that is easy to install and great to operate. Here are the technical details, all summarized in our sell sheet. You can see the product specification, standard thickness pitch, 8 millimeters, standard thickness, 5.6 millimeters, just the same as a standard HDD8 belt. We make that in roll length of 100 meters, and the standard version is with nylon fabric on two sides, but it's also available with nylon fabric on both sides. And you can see standard width is start from 25 millimeters up to 150 millimeters, which is a major advantage versus our competition. And we have two polyurethane versions available, which is our standard R1, and which is a 92 Shore A material, pliable for a temperature range of -5 to +70 degrees C. Optionally, we can make it with an R23 low temperature resin, which is a 90 Shore material, and that works from -30 to +55 degrees C. The minimum pulley diameters are the same like with standard HDD8 belt. So minimum pulley diameter 80 millimeters for applications with no back bending, and with back bending we have to increase the minimum tooth count of to 38 teeth instead of 31 teeth with no back bending. So here is the pulley design. As you can see, the pulley is composed of three main parts. Two tooth pulleys, part 1 and part 3, that are attached to each other such that the teeth are offset by half the pitch, which you can see here. So the left side and the right side of the tooth sections are offset by half the pitch. The offset is secured by 3 dowel pins. So these are the dowel pins that secured the exact and precise offset of half pitch for the tooth part. The tracking ring, part number 2, is placed between the two pulleys. The tooth geometry of the pulleys is standard HDD, which you can get from any pulley manufacturer. If you have any questions about the pulley design, Gates TPU can assist by providing design recommendations and examples, or offer belt and pulley. Here are major potential applications and market segments. As you can see, they are all in demanding high precision, highly dynamic applications, most in lifting or linear actuation applications, material handling, vertical lifting, material lifts and automotive production lifts, automation, of course, linear actuators, XYZ gantry systems, where it's important to have high acceleration, strong cords inside, and also with low noise and nice and easy tracking. And of course also intralogistics, which is a really booming market segment. The ASRS systems and any material handling intralogistics is one of our major application fields of application. That's our just a, let's say, a selection of applications where we envision to be the SST belt most favorable versus our existing belt designs. The target audience is OE and replacement who have slightly different requirements, but all are driven by cost saving and safe operation. Cost savings accomplished by easy installation, less installation time, and less downtime by increased lifetime. Safe operations employees working close to the drive will enjoy a reduced noise and vibration. For both, Gates is on your side to provide technical resources and input on product application. So who are our competitors? Our competitors offer this HOT belt solution, which was attempt to have the same features like self-tracking and low noise. And what you can see is the competitive systems. And we started to look at the 8mm pitch because this is so far we believe the most popular pitch. And we started to develop our alternative SST8 RSL in the 8mm pitch. So what you can see here is that the belt is competition start with 16mm in belt width and reaches up to 50mm in width, whereas our belt, we improve the strength of our belt and we make it up to 150mm in width. So providing a 3 times higher braking force and allowable forces versus our competition. That means that customers will only need one belt when they apply higher loads compared to multiple belts from our competition. If the market accepts our belt design, we will be happy to add more pitches as required. Here we, of course, during the development process, we looked at our competitive products, and here the benchmark shows that Gates SST8 RSL is in line with competition up to 50mm in width. So braking force pretty much the same like what everybody else is doing. Over that 50mm width, Gates SST8 RSL is unique and handles up to 3 times the load of competitive belts. Not only the load and braking strength is important, but also the effective forces. And here this benchmark shows the allowable effective force that standard HDD is in line with our competition. However, since the tracking ring reduces the tooth belt width, the allowable force is reduced by the width of the tracking ring. Even if HOT belt has a similar gap of tooth width of the pulley, these belt manufacturers publish a higher allowable effective force. The difference declines with the increased width of the belt. However, the next page will show us the reality between publish and practice. Here is the result of our benchmark test. Both belts ran in the same test bench with the same parameters. In order to accelerate the test, we applied 104% of the maximal allowable effective force with no safety factor. The test end of both ends for both belts was the wear in the land area and or the tooth flank wear. So you can see the land area where the cord already is exposed, and what you can see how the pulley looks like after the cord is exposed, and the cord directly runs on the top of the pulley tooth, so it wears the pulley tooth off. Similar with our SST8 RSL belt, and you also can see the flank wear. That is determining the end of the belt test. Both the belt looked very similar after the test, but the Gates SST8 belt ran 6 million cycles, 5 times longer than the HPL belt from competitor 1. So that gives you an idea about the belt looking similar because we really overloaded the belt, but our belt ran 6 million cycles versus our competitive belt runs 1.2 million cycles, even if they publish higher effective forces than we do. If you are shocked about how the belt looks like, of course we've overloaded the belt on the test. Otherwise, it would last too long. Applying the correct loads and the safety factors, of course, will result in correct belt performance and lifetime. In another test, we wanted to learn how the noise level compares with the competitor HOT belt. We asked our colleagues from Gates Automotive Noise Laboratory if they could come to a customer who ran an HOT belt in their automated warehouse test center. Fortunately, we have the opportunity to use the Gates R&D resources, and especially the automotive colleagues are extremely professional when it comes to noise measurement. And so they came with an impressive mobile equipment called artificial head to measure the noise generated by the installed HOT belt. The same day, the drive was changed over to Gates SST8 RSL belt, and the same noise measurement was done in the same condition, in the same equipment, and of course with the same drive parameters. And here is the result. The blue lines show the Gates belt level, and the magenta lines show the HOT belt. What you can see here is the noise level is at about the same level between both belt designs. The maximum differences can be upward to 0.5 to 1 decibel, and that's really minor. So this is really showing that both configurations almost have the same shape and the same level of noise and vibration. Why Gates? Because we are trusted partners of our customers with over 100 years of experience, always leading in innovation and providing the highest performing belt product. Our technical expertise is always available to our customers by training programs, by our sales teams, and our application engineers. Why SST8 RSL? Because it's another superior Gates product, solving problems in demanding applications when the belt does not want to stay on the pulley or when high lateral forces destroy the pulley flanges. It's saving installation time, taking higher loads than any competitive belt, and runs smoothly and quiet. Please reach out to our application engineers to define the best belt pulley combination for your application. We optimize our customers' operations. By innovation, we continuously develop new products, achieving improved properties to increase performance and reduce downtime for increased profitability of our customers. By improving processes to ensure quality and reduce CO2 footprint of our organization as well as for our customers. And we care about the environment. Gates products are lighter and more efficient, resulting in less energy consumption. At Gates, we know you never stop, neither do we. Please reach out to us to explore your improvement opportunities. Our supporting marketing materials include this webinar is recorded, so you can we will publish the site where you can download the webinar and have access to the webinar at any time you want. We have training presentations to download. We have the sell sheet. You probably are aware of that with the emails sent out to you. You always can download that from the Gates website. And of course, we have our experienced application engineering support that is always on your side to specify and calculate the specific application in your area. So this completes the information that I wanted to show you today. It has been quite quiet so far. I would ask you for, if you have any questions, if you have any comment and feedback, please unmute yourself and raise your question. We have time enough for that. So I don't get any, don't know if there's no, you can use the webinar chat system in Teams, or you can type into the question and answer. There is a question if it's possible to have a 16 millimeter width belt. Theoretically, yes, but because of the width of the reduced belt or tooth width, because of the tracking ring, we didn't offer 16 millimeter in width, because then the effective force is really limited, and it does not make much sense to have it in 16 millimeter width. I know that competition does have it with HOT belts, but for SST8 it doesn't make much sense. Hope that answers your questions. Okay, otherwise there's no open questions for now. Longitudinal module, I'm not sure what I can understand, what longitudinal module is. Can you please explain that to me? The stiffness of the cord, yeah, we have a reinforced cord, which is the RSL belt, and we can go back to the technical page. Here we go, and what you can see here, we have a specific belt stiffness data, and here you can see the specific belt stiffness in newtons, and we have the equations and the technical calculation of how that compares to elastic elongation in our catalog, in the technical part of our catalog. And with this belt stiffness data, you can calculate the elastic elongation of the belt. But I can assure you the stiffness is very high since we've applied the RSL steel cord version, which is the really high strength steel cord. Another question came up. Presentation is targeted to HOT belt. How does the SST belt compete against the standard belt, standard HDD belt? the belt construction itself is the same like a HDD L8 belt, which is mentioned here. When you can see the HDD standard HDD8 belt, and we are completely in line with standard HDD8 belt. Also with our competition. So the allowable effective forces as well as also the braking force is completely in line with competition and also with our standard HDD L8 belt. Okay, there's another question for to show the pulley slides again. 1 second, I just have to look it up. Where do we go? Here is the pulley design, and I can repeat that for you. So we have basically 3 major parts of the pulley, which is two tooth parts, the part number 1 and 3, and the center tracking ring, part number 2. The 2 pulley parts are offset by half of the pitch, and the offset is secured by the dowel pins that are placed such that the offset, the half pitch offset, is fixed, and the center tracking ring is in the center of in the middle of these 2 tooth pulley designs. So when you want more information, please reach out to our application engineers and to your Gates contact. We can provide additional information to you if you want. Next question is an information about permissible lateral forces. That's very application specific. So we so far we don't have any data for maximum lateral forces because that's also depending on the center distance of the pulleys, and so we currently have no data that we can provide. But what we already have seen in customer application, where we had a competitive HOT belt that where the pulley wears the teeth away from the belt, and we applied our system, and that is running without any problems. So that is definitely a major advantage, and one feature that we wanted to improve versus the current HOT belt construction. Another question came in if we have pulleys in stock. No, we don't have any pulleys in stock. Since most or almost every application requires a special pulley design with different belt widths, with different shaft and pulley connections, with different bore designs. We have these pulleys are mostly made to order and made to drawing, and therefore it doesn't make any sense to have pulleys in stock. Another question is if we compare the load characteristics of SST8 RSL and in 100 millimeter width and other competitors 14 millimeter pitch. Not sure if I understand the question correctly, but as already mentioned, the SST8 RSL is the same basic belt construction like our HDD L8 belt, with the reinforced cord. Our standard 14 millimeter pitch, as well as the competitive standard 14 millimeter pitch, has the same steel cord applied. So the breaking force and allowable force, belt force would be the same. However, of course, the 14 millimeter pitch would provide higher effective forces. Another question is if we have a chance to study the design of pulleys for SST8. Of course, we did make some pulleys for our internal belt testing. Of course, we have some experience of how to design this type of pulley, and we can provide you with examples of drawing how we did it. And please reach out to our application engineers who would be available for you to have drawings that can give you help and support how to design your pulley for your specific application. Another question, is it possible to calculate tensioning force for long distance between pulleys? Yes, of course. That's our standard day-to-day process. We have a technical calculation method which is included in our catalog. And if you don't want to do that by yourself, you always can reach out to our application engineers. We have applications in the center distance of pulleys up to 20 and 30 meters. So that's our day-to-day business, no problem. Next question, which company are selling the special pulleys? Pretty much all pulley manufacturers can make this type of pulleys. So as that is one of our design targets and design goals, that we make it easy for everybody to make these pulleys. So this HDD 8 millimeter tooth design is very standard, and pretty much every single pulley manufacturer can make that, and the pulley manufacturers also can do this design with the dowel pins and the center tracking ring. So that is easy to make for a pulley manufacturer. Okay, so that seems to be the questions that came in so far. And I'm really happy that there's coming questions in. So that shows me that there is an interest, and I know that the pulley design is something special, but we try to really make it easy. A lot easier compared to the HOT belt, which is a lot more complex and a lot more complicated to make. And as I said, there is only very few pulley manufacturers who can do this HOT belt design. Okay, if there is no other question coming in, then I would thank you for your attention. It's great to get the questions back, and if other and additional questions come up, please don't hesitate to reach out to your Gates contact. We are always happy to answer your questions, to help you with the application of our product, especially the SST product, which is really a great thing. And we really would like to see more and specific applications where our belt is really outperforming any competitor belt, and basically help the customers to do the belt installation, to make it more easy, save time with it, and have a better and more quietly running belt system versus any other product. So for now, thank you so much for your attention. I really appreciate it, and I wish you a great rest of the day. Great success with our SST belt design, and thank you again. And whenever any question come up, please reach out to your Gates contact. Thank you so much.